Okay, here we are back in the library, and we're going to go through section 13.1 for chapter 13 on three-phase induction motors. And 13.1 is called principal components. There are two primary parts designated in a three-phase induction motor, and those two parts are the rotor and the stator. And just as the name would imply, the stator is stationary. It does not move. And the rotor is the part of the motor that turns. And so we're going to look at this. We're going to break it down and look at some actual motors now and try to start making sense of some of this stuff. So let's switch over to that screen. Okay, so here we go. Now, everything from here on, you know, is going to be very, you're going to see a lot of real world examples, okay? And so here is a motor. It's a three-phase induction motor. You'll know all about how to know that very soon, because you are going to be expert in being able to pull the data off of a nameplate on a motor. It's just a great tool to have when you're working in this field. So this is a motor. It's a 10 horsepower motor, okay? And even though the horsepower is not our SI units, we know the conversion for that. I am probably more comfortable in talking about horsepower in terms of motor output. But, you know, we need to make sure that we're able to do the conversions. One primary reason for that is the fact that so many of our equations are going to be derived in terms of power output in watts. So we want to be able to make sure that we're able to do that. Now, this is a pretty big motor. You know, it weighs 90 kilograms, he says, okay? So, you know, that's a, you know, if you multiply that by 2.2, you know, 180-ish, close to almost 200 pounds, okay? So it's a big motor. And anytime that you look at a motor and somebody says it's 10 horsepower like that, what that means is that is the power available at the motor shaft to do work, okay? Now, there's power that goes into this motor. You know, we bring actually into here, I should say, because that's our connection for our wires, but you know, we bring our electricity, three phases of it, and we'll get into all that three-phase thing here very soon. But I bring the power in, and I have some losses in here, right? And we looked at all about losses in some of the earlier chapters. And then the power in minus the losses gives us the power out of the motor. Now, this particular motor, he says it's 91.7% efficient. So, you know, that's what we're looking at here. So there's that part. He also says on here that the motor is rated at 1,760 RPMs. Okay, so most motors, well, all three-phase AC induction motors, they pretty much maintain their rated speed across the range of load. And that's a characteristic of an induction motor. We'll talk about more of that later. And it's a 460 volt motor, okay? That's a higher voltage than we're used to looking at. Three-phase, 60 hertz. He says it's a totally enclosed, fan-cooled. We're going to find out that, and this would be the actual abbreviation for that, you would look this up. But every motor is going to have an enclosure that is adapted to the environment that it is placed in. It says it has a full load current of 12.7 amps. You'll see that abbreviated on the in the text and on the nameplate as FLA, full load current. Okay, so that's you know, something that we want to be able to pay attention to. It has a power factor of 81%. Okay, so that tells us something in terms of the motor, in terms of its power factor. We'll go into some examples of that. It tells us that the no load current is 5 amps. So in other words, when we look at, just the current expenditure just to make this motor turn, even without a load, is 5 amps. It has a term on here called a locked rotor current, and it says it's 85 amps, okay? So that is the very brief amount of current, or the very brief time that it draws its startup current. It gives us locked rotor torque in 2.2 per unit. So what that means is, and we have formulas for all this stuff. You know, you have the motor has a certain amount of torque at rated load, but at the locked rotor torque is 2.2 times that. And we have these charts that we'll look at. It has a breakdown torque of 3.3 per unit, which means that if you were to apply a load that was too much for this motor in its rating, and you were in excess of 3.3 of the rated torque, you would cause the motor to stall. That's called the breakdown torque. We have a service factor of 1.15. That means that we could run this motor above its rated output by 15%. And we'll talk about whether we can do that continuously or for brief amounts of time. I already mentioned the total weight. The length is given 491 millimeters, about half a meter. And the overall height is about 1/4 of a meter, 279 millimeters up. And this length, the axial length or overall length, including the shaft, is 491 millimeters. Okay, so all of that information is something that's given to us in this example. And it's, talking about the motor. Let me point out a couple of things here. This very simply is a method to take a almost 200-pound motor and, hook a crane to it or some other device to lift the motor, put it into place. These fins that you see on here, this is designed into the motor to help it dissipate heat. Also looks like there is, it's got these end bells to keep everything internal of the motor, protected here and here, but we can still, looks like we can draw air into this as well. It's a totally enclosed, fan cooled. And so anyway, all this information that we just went through, it all is on this nameplate, and we'll go through a way and we'll get to where we can understand that. I'm going to stop the first video here, and we'll make a second one to break this down a little bit further.